In this class, we're going to discuss connection-oriented transport protocol. It is a transmission control protocol. The connection segment structure of TCP, sequence numbers and acknowledgement number of TCP, and reliable data transfers. Few interesting scenarios and very first scenarios and second, third, and scenario. How fast retransmit will be taken place. We want to discuss in this class. As you know, that transmission control protocol is a connection-oriented protocol. It is also called as a point-to-point protocol. So why it is a point-to-point protocol? Because it is a one sender and one receiver. It is exactly, so we have to transmit the messages between one sender and one receiver. That is the reason it is a point-to-point protocol also. And connection is established between sender and receiver. Then we can send and receive the data. So as you defined, so this TCP is defined under RFCs 793.1122.1323, 2018, and 2581. These are the some of the RFCs which are defined. It is a reliable in-order byte stream. No message boundaries are available. Why it is a reliable? As you sending the data, so we are expecting the acknowledgement. Handshaking procedure will be done at the in TCP protocol. So again, it is a pipeline. So why it is a pipeline? It is a TCP congestion flow control and set window size. Already it is defined, and it is a pipeline means at a time. So we can able to send 3 packets at a time. It is also possible. Congestion will be controlled and flow controls. So any packet congestion is occurs that should be controlled, and so data flows. So how many how many packet can accept by the receiver. So depending upon that, so that is a packet will be sent by the sender. That is the flow control. Full duplex data. So bidirectional data flow is the same connection. So it is a full duplex data. It is possible in case of TCP. So it is a bidirectional data flow. So data will be as connection is established with the sender and the receivers. So in between devices like switches or routers. So we can bidirectional data flow is also possible. So with the same connection till connection terminates. So maximum segment size. So we can able to send MSS stands for so maximum segment size, allowable size. So depending upon the bandwidth is available, so we can transmit that segment. So in case of TCP, it is a connection-oriented protocol. So handshaking will be done before sending a data, exchanging of control messages. So initiate the sender and receiver state before data is exchanged. So I will tell you. So what are the handshaking? So that is a procedure will be taken between the sender and receiver. So before sending any data. So flow control means sender will not overwhelm the receiver. So it is because already I told. So the sender size, window size is defined. Receiver window size is also defined. So receiver window size always by the accept by the sender, and vice versa. Sender will also accept by the receiver window size. So that is before sending a data, it is both the sender and receiver agree. So how many pipeline data? So parallelly, so 3 packet at a time, 4 packet at a time, 5 packet at a time. So it is already depending upon the window size. So both the sender and receiver agree that so the size of packets, how many the size of this is segment structure. These are the bits which are available in segment structure. As you know that it's 32 bits, source port number and destination port number. So it is a sequence numbers. So packet it is a sending acknowledgement as and when the packet is delivered to the receiver. Acknowledgement number will be generated based on the sequence number. Sequence 1, acknowledgement 2, acknowledgement 1, sequence 2, acknowledgement 2. So like that, it is generating the acknowledgement numbers. So here, and acknowledgement number when it is generating, if it is your data is delivered to the proper destination, so our corresponding machines. So immediately without any data loss, so acknowledgement number will be also generated by the receiver, sent back to the sender. So every data, so or every segment, so we are getting the acknowledgement back to the sender. So that is the beauty of transmission control protocol. Again, push data flow. So these are all some UA. So are the flags. So that is a flag will set as and when data is delivered. So use so that is a exactly U is a so urgent data. So that is exactly generally not used. So again, A is acknowledgement as and when so data is delivered, acknowledgement flag will be set. So P is the so push data flow. So generally it is also not used this flag. R is the reset or synchronize finish. These are all the for correction establishment. Reset, synchronize, and finish. This is the correction establishment. Setup, tear down commands. So normally in the handshaking procedure, I will explain you these correction setup commands. And F is that. So that is nothing but a finish. So that is a R, S, T. R is reset. So RST is a reset, synchronize, finish. These are the flags as and when. So connection establishment will be taken place, set up and tear down. So set up the connection and shut down the connection. These flags will be set and receive window. So this is how many number of counting in bytes of data, not segments. So how many number of sequence number. So it is counting in terms of bytes. Again, receive the window. It is also counting in terms of bytes. Receive how many packet has been received or accepted. Okay. So by the receiver, again urgent data pointer option variable length field. It is an internet checksum. So always checksum will how much of the bits having error and how much of okay. So segment has been error will be checked by the checksum field. Application data. It is a variable length. It is always application data. So along with this so header and this so application data is also available. This is a TCP segment structure. So TCP sequence numbers and acknowledgement concern. Sequence numbers, it is a byte stream number of passed byte in the segment data. So sequence number will be generated as we are sending a data so per segment. So data in the form of a segment. So sequence number is also generated for each in the byte stream. And number is the first byte is the segment's data. So sequence number one, sequence number first, second byte. So that is again sequence number two, third byte, sequence number so three, like that. Each and every the byte of data segment number. So segment sequence number will be so added. Acknowledgement will be received. So back to the sender. So segment is accepted and received. So this is the sender sequence number space. You see that so acknowledgement is received back to the expected from the other side. So cumulative acknowledgement. Again, sequence number one, acknowledgement is sequence number zero, acknowledgement of zero. Sequence number one, acknowledgement acknowledgement number one. So like that, as and when the receiver is receiving the so the segments, acknowledgement is also generated by the receiver, sent back to the sender. How receive handles out of order segments. So TCP specification does not say to how to implement that. So that is exactly we cannot handle the out of order segments. So whichever the segment is received, so particular acknowledgement will be generated and back to the senders. So here TCP sequence numbers and acknowledgements. So you can see one example, host A and host B is available here. So user type is C. So sequence number 42, acknowledgement number 79, data is equal to C. So host is accept this acknowledgement, receipt of C echoes sent back. So that is you see that sequence number 79 sent by the host B, acknowledgement 43, data is C. Again, host acknowledgement receipt. So again, receipt will be sent back by the host A to the host B. Sequence number 43, acknowledgement 80. These are some handshaking procedure like some sequence numbers are generated with the acknowledgement. So here TCP round trip time and out TCP timeout value. So how to set the TCP timeout value, that is a question. Longer than one round trip time, but RTT it is also varies. It is a too short. The premature timeout it is occurred. So in the okay, unnecessary retransmission will be taken by place from the sender to the receiver. If it is a too long, so responded from the receiver back to the sender. So it is a slow reaction to the segment loss. Some segment loss, slow reaction will occur again from the sender to the receiver. How to estimate the round trip time? Sample round trip time measured in terms of segment transmission until acknowledgement. So as a segment has been transmitted from the sender to the receiver, so we can get back acknowledgement until that. So one round trip time should not complete. So ignore retransmission. Sometimes ignore the retransmission because it's a one round trip time. It is acknowledgement. So till timeout period. So that is acknowledgement is waiting. So then only it is a one round trip time should complete. Sample RTT will vary. Want to estimate the round trip time smoother. Average several recent measurement, not just current sample RTT. So RTT stands for it is a round trip time. So here TCP round trip time and timeout estimate round trip time. So one alpha it is into estimated round trip time plus alpha sample round trip time exponential weightage moving average. So this is exactly influence the fast sample decrease exponentially. Fast typically value of alpha it is calculated. So this is the value of estimated round trip time. So with that this is the packet movement that is a sample. Sample shows with the one complete round trip time. So again, it is a estimated round trip time. This is the estimated round trip time they are calculating here. So TCP round trip time and timeout. Timeout the interval estimated round trip time plus safety margin. Large variation in the estimated round trip time. So is greater than largest safety margin. Estimated sample round trip time deviation from estimated round trip time. So deviation RTT is to be calculated like this: one minus alpha beta at the deviation RTT. Beta into sample RTT minus estimated RTT. Typically, beta value is given here. So timeout interval and estimated RTT plus 4 into so deviation RTT, the safety margin and estimated round trip time to be calculated. We can calculate the timeout interval accordingly. Here TCP reliable data transfer or not. So is it TCP is a reliable data transfer? Yes. TCP creates a reliable data transfer service on top of IP unreliable service. So it is a because pipeline segments. So at a time we can able to send so 3 packet or 4 packet at a time depending on the window size, and cumulative acknowledgement also received from the sender back to the receiver, and single retransmission timer. It is a starts so from sender sending the packets so at a time, so either one packet or the two packet, depending on the window size is defined and accepted with the receiver. Retransmission triggered by timeout events. So again, suppose it is a timeout events, so certain packet not received by the receiver. So retransmit that so by the same packet by the TCP protocol. Duplicate acknowledgement so may occurs because of duplicate acknowledgement so will be discarded. Let us initially consider the simplified TCP sender, ignore the duplicate acknowledgements and ignore the flow control and congestion control also. So here TCP sender events, data received from the application creates a segment with a sequence number in a byte string, number of first byte of data in a segment, start that timer if not already running. Think of timer as per oldest acknowledgement is already sent. Expiration of interval, timeout interval will show. Timeout interval means retransmit the segment with the caused timeout. Suppose if it is a timeout period is set as a start timer is sending the packet, retransmit the same so as and when timeout period is retransmit the same segment which is not getting any acknowledgement. So that is a restart the so again timer. So acknowledgement is received if acknowledgement is previously unacknowledged segments. If acknowledgement is received, okay, but previously unacknowledged segments, sometimes it is also received. So update the whatever the known to be acknowledged, start the timer. If there is a still unacknowledged packet segments of data is to receiver, so that has to be also, so you can start the timer by the sender. These are some of the events to be occur in the sender side. Similarly, so the TCP sender, it is a simplified. These are the some of the FSM, binary state machine, data received from the application above, create the segment sequence number. So this exactly next sequence to be followed. If timer currently not running, start timer and timeout period, retransmit not yet acknowledged packet, acknowledgement received with the acknowledgement field value. These are the 3 events is occurs. So this is, I think there is a already I've explained this event of TCP sender also. So similarly here, the TCP retransmission scenario, host A and host B. So assume that it is a host A is sending a sequence number 92 with the 8 bytes of data. So acknowledgement, so 100 will be sending in the sequence and acknowledgement not received. Again, sending retransmit the same sequence 92, 8 bytes of data. Now acknowledgement 0. So the acknowledgement number is 100. This is the last packet, how exactly acknowledgement will be getting back to the host A from host B to the host A. So then now in this case, acknowledgement is getting back to the sender. So this at a certain time out, period how retransmit again by the same packet. From this we are observing here. Here premature timeout. So this scenario premature timeout. So how host A, host B, premature timeout. You see that send base 92, sequence 82, 8 bits of data, sequence 100. So this is the pipeline data. It is an unpipelined data. So here sequence 100. So 2 packet at a time, 20 bytes of data. Acknowledgement 100, acknowledgement 20, and 120 is sent by the host B to the host A. So again send base 100, 120 is received here. So again, so that is exactly after certain timeout sequence 92 bytes of 8 bytes of data is ending. So this is exactly premature timeout. Already it is a so timeout is occurs till so premature. This shows the premature timeout. So in case of so the retransmission scenario concern. Again, you see here there is a cumulative acknowledgement. So host A and host B. So 2 bytes of 8 bytes of data and 20 bytes of data in sequence number 92 100 sent by the host A to the host B. Acknowledgement 100 has been delivered back to the host B to the so host A. So it is our acknowledgement 100 is not received by the host A from host B. So it is the last acknowledgement is last. Acknowledgement 120 only received by the so host B to the host A. Again, it retransmit that. So whichever the so it is a so 120 that is the cumulative acknowledgement. Cumulative acknowledgement will be so retransfer. So this is certain timeout is available. Again, it retransmitting that. So whichever the acknowledgement is not received. This is what cumulative acknowledgement. So TCP acknowledgement generation defined under RFC 1122, RFC 2581. Event at receiver, so TCP receiver action, arrival of in-order segments with the expected sequence number, all data up to expected sequence number already acknowledged. So arrival of these are the events to be occur, arrival of in-order segments and arrival of out-order segments with a higher expected sequence number and arrival of the segment with partially. I think at this acknowledgement generation, so these are the event is occurs. TCP receiver event. So I will delay the acknowledgement wait up to 500 milliseconds. So that is for the next segment. If no segment send the acknowledgement, immediately send the single cumulative acknowledgement with the both in order segments, and immediately send the duplicate acknowledgement indicating the sequence number and next expected byte. Immediate send acknowledgement provided that segment starts at lower end of the gap. So TCP fast retransmissions. So timeout period often relying long delays before resending the last packet. So detect the last packet via duplicate acknowledgement. Send oftenly sends the many segments back to back. So that is a fast retransmission. If the segment is lost, there will be likely to be many duplicate acknowledgement definitely it is received. So as and when many duplicate acknowledgement, so it is indicating that so segment is lost. So at that time, you get the last segment and so fast retransmission will be taken place. TCP fast retransmit, if the sender receives 3 acknowledgement for same data, so it is a duplicate acknowledgement is received. So it is understand that yes, that data is not received. So the one data has been sent, but 3 duplicate acknowledgement is received. At that time, the fast retransmission of the same data with the smallest sequence number, likely that unacknowledged segment is lost. So don't wait for the timeout period. Don't wait for the timeout period. 3 consecutive acknowledgements say that. So you retransmit the same data. That is the fast retransmission. So here scenario is one scenario for fast retransmission. So sequence 92. So with the 8 bytes of data, sequence 100 with the 20 bytes of data sent by the host A to the host B. So sequence 120 bytes of data is last. You see that other data has been received. Acknowledgement 3 acknowledgement is generating. So it is again so it is not wait for the timeout. So again retransmit the sequence 120 bytes of data again. So this is the fast after sender receipt of the triple duplicate acknowledgement. So you see that triple duplicate acknowledgement has been received by the so host B to the host A. So that so does not wait for the timeout period. So it is a fast retransmit after the so receipt of triple duplicate acknowledgement. So in this class, we have discussed about connection-oriented transmitter protocol, TCP connection, segment structure, sequence numbers and acknowledgement numbers, reliable data transfer, and some interesting scenarios So first and second, third scenarios and past retransmission, how exactly taken that scenarios also we have explained here.